Hello everyone. We will be solving the fourth problem of the contest, right? We will start from the fourth. We will move on to third and second as well. We'll be uploading those, and I'm thinking of doing the code forces round as well. Bit late for this, but yeah. Let's look at the problem statement now. The problem name is minimum number of string groups through transformations. You are given an array of string words. We define a transformation on string as follow. Let e be the subsequence of characters at even index of s. Let o be the subsequence of character at odd index, right? Independently cyclically shift e and o by any number of positions to the right, which can be possibly 0. You need to reconstruct the string by placing the shifted E characters back into the even indices and shifted O characters back into the odd indices. Two strings are equivalent if one can be transformed into another by single transformation, right? And you need to partition words into minimum number of groups such that every string belongs to exactly one group and every pair of string in the same group are equivalent, right? You need to return the minimum number of groups. So the problem is bit of a lengthy problem, right? Let me break down to you in simpler words. Let's take a test case just to be clear. First, ntgwz. So the first test case is ntgwz, and the second one is zwntg. ZWNTG, right? So these are the two strings which are given to us, right? We define each string as the even indices. Let's call this 0, 1, 2, 3, and 4. So this is at even index, this is at even index, and this is at even index, right? So the each string from this place is NG Z, right? All right. And the string odd from this is T and W. Yes or no? Let's take the string from this place as well, right? Let's start with 0, 1, 2, 3, and 4. So the string E which will be there is Z, N, and G. So Z, N, and G. And the even string is W and T. So what does the problem state? The problem states that you have these two strings, right? You store it, and now you tell me if you can cyclically shift this one, right? You can oh my goodness, you can you can cyclically shift these two strings E and O, right? And you need to tell how many different pairs will be formed. You need to tell in how many minimum number of pairs will be formed. uh, it might be a bit tricky. Let's see what does this mean, right? Let's take this E from here and E from both E strings and let's compare it. So as of now you can see the E string E1, let's name this N, G, and Z, and let's name this as E2, which is Z and G, right? If you look at it, what happens if we cyclically rotate this one to the right, right? Means cyclically means rotating it to the right. So this Z will come in the front, this G will shift here, and this N will shift here, right? So ultimately it would become Z N G. So E1 has become equal to E2. That is great. But what about O1 and O2? Let's look at that as well. So O1 is TW, right? And O2 is WT. Again, you can cyclically rotate this and you will see this will becomes WT, and now both are equal, right? So we can say, hey, we can pair them, the string S1 and S2, and these two can be paired up. Why? Because every pair like index even subsequence and odd subsequence of both of the strings matched, and so we can say that both are in the same pairs, right? So you need to return the minimum number of pairs, right? Return minimum number of pairs. And one more thing, let's say if there were three strings, then they will also form a pair, right? Means these are considered to be a single group, right? Don't misjudge that if only two elements will be pairs, right? The problem states that any of the three or m number of strings are there, if they are having same e1 and e and o respectively, then that will be in the same group. So I hope the problem statement was a bit clear to you. Even if it's not till now, we will understand it more as we proceed in the video, right? If you look at the time constraints, you can look out at the other problem test cases as well if you have any doubt. If you still don't get it, be in the video, right? If you look at the time constraints of the problem, the word dot length is 10 to the power 5, uh, and every word of I dot length can be till 5 into 10 to the power 5, but sum of the word dot length does not exceed 5 into 10 to the power 5, right? This third constraint is very important. What does this mean? The sum of the words length, right, words of I, does not exceed 10 to the power 5. What does this mean? That every element in the string, if all the elements are counted together as well, still that won't be greater than 10 to the power 5. This gives you a hint that hey, the solution which you can write can be big of n. N is a number of string in the vector, right? And into m, right? M is the size of the string, right? Size of each string, right? So this can be a this solution will get accepted for you, right? Okay. So now let's think of the problem, right? So when I first, let me give you my intuition. When I first thought of the problem, I thought that, hey, can I apply DSU on this? And as soon as I thought a few cases, it soon rejected me with, hey, no, you can't apply DSU on it, right? And the reason for that is pretty simple. The reason is you can't map the string, right? Let's say you have a string s, right? So you don't know that this, when you can, if you cyclically rotate it, right? Let's say if you had string, let's take an example, let's take the string abc. Now before, let's quickly look at it. So if you cyclically rotate it, it will be abc, the second string will be cab, third string will be BCA, right? So these are the three possible strings that can be formed, and you don't know which string to take, right? Or which string to put in in our DSU so that we can have it as a group, right? So that is the reason that will fail, because if you know something, if you know about DSU, then you might know that ABC will be put in a group, right? Let's call this, let make this as a black box, right? And now any other element, any other uh, string, if that has a even subsequences as abc, then it will be put in this, right? So you have to try all the possible subsequences, or rather cyclic rotations of a string. That will cause a huge number of collisions or huge number of elements in our DSU, right? So that is the reason we are not thinking towards DSU. I'm not pretty sure that it can be completely ignored, but my thought process doesn't allow DSU in it, right? All right. So then what is the solution? See, before jumping to solution, you must have a clear thought of proceeding in the solution, right? So what I thought for this problem is, first things, the first step is very obvious, right? Segregate or separate, right? Separate the even and odd strings, right? You can find even and odd strings. Now let's see a very great property, right? What is a great property here? Let's say if I had a string ABC, right? And you saw the cyclic shifts could be CAB and BCA. How would you find these cyclic shifts, right, of this string? This can be done is in a way, in a smart way, that is, you can write ABC and again write ABC, right? Now the first string represents this ABC. If you move to the second string BCA, see, this is the second or the any positions, this string, then again CAB, this is this one, right? So you can see all the cyclic shifts which are there can be found if you multiply a string of size into n into 2, right? All right. So now what we can think of, if I say, hey, you have segregated the things, you have found the E1 string and O1 string. Now do one thing, you find all the rolling hash value. Now you will say, hey man, what is this rolling hash value and how, like, what is this? I will explain this to you. It is a very great algorithm, right? And it is generally used to see if a string T is a matching of string S or not, right? We won't be matching any string. We will be using the rolling hash in a different manner, right? What my claim in this problem is, we will find rolling hash value for every cyclic shifts. For every shifts, we saw that how we can find the cyclic shift of any string, right? So what we will do, we will find rolling hash value for every cyclic shift, right, for the string which are there. And after finding it, we will put the values, the minimum value in my set. Now see how brilliantly we will think. Let's say if there is a string s1, let's name this as e1 and the o1, right? So we will form a pair of these, right? E1 will give you a rolling hash value. Let's call this value as of now, let's say 1 2 3 4, and let's say o1 has given a value of 5 6 7 8, right? Now you put this pair into your set, right? 1 2 3 4, which was, this was the minimum out of all the cyclic shifts. That means ABC, and let's say ABC was there. This was my first string, this was my second string, this was my third string, right? So this give you a value of something, let's say very big number. Let's call this number as x. The second give you a y, and the third give you a 1 2 3, right? 1 2 3 4. Now you are saying that, hey, I will store the minimum value at every point, right? Storing the minimum value ensures this, that every time you have an you don't create an ambiguity when you are solving the problem. Like for any other string, you, if you have this bca, let's say bca created the minimum, or rather cab created the minimum value 1 2 3 4, right? So in other time, whenever there is a string, the rolling hash will ensure that if you get a cab, then only you get a value 1 2 3 4, right? So we are making sure that we store the minimum value. You can store the maximum value as well. Any case will ensure the correctness of it, right? So store the minimum values, like we are storing the minimum values, right? So we will store the minimum values in of this e1 and o1 in our set 5 6 7 8, right? Now let's say in future another string, let's call this as e3 and o3. This also created a value 1 2 3 4 and 5 6 7 8. This means the rolling hash makes sure that you found this value with the same string cab, right? Now what have the smartness we done is, we are using a set, right? Now set will see, hey, this value already exists in my container, right? Then I won't push the element in my set. Pushing the not the element in the set ensures that this is a pair, right? So what I can say, I will find the rolling hash value for every element, and the number of elements in my set will be equal to the number of pairs. Yes or no? Is this thing clear or not? Because set does not contain duplicate elements, right? So if it does not contain any duplicate elements, then this value will definitely store the if value repeats, then we were sure that these are going to form a pair. So if five numbers are forming a pair, 1 2 3 4 5 6 7 8 wala pair, then we can say, hey, all of them are in a same group, right? So we understood the gist of the thought that we are going to find the rolling hash value, and that rolling hash value will be put in the set, and the set dot size will be my answer. Yes or no? Is this thing clear to you? Now the problem is almost over, right? Because the only thing we need is to understand how we are going to find the rolling hash value, right? So if you know the rolling hash value, the video is almost, I will give you the timestamp of the code. You can directly jump on that part and see the code of it, right? If not, let's try to understand the rolling hash for your case, right? Now let's understand how rolling hash works, right? So let's say if I had a string ABC, right? I am taking ABC because it's very obvious, it's very uh, easy to understand, right? So that's the reason I'm taking ABC. And what we did is we duplicated the element ABC again, right? Now how do we find rolling hash value is uh, let me explain from scratch. What happens in rolling hash, let me write it with a different color. So you are given a string, let's call it xyz abc, and you are also given a string t which says yza. You need to find that, hey, if this string exists in this s or not, right? So what happens is when you apply the brute force in it, when you do a brute force, what do? You check every element, you see, hey, does this element matches with this character? If it matches, you start your two pointer approach, right? You will then check for every element index in J, and if it matches every index, then you will say, hey, I have found my string, right? But this thing takes big O of, there might be a worst case. What can be the worst case? You traverse till the end of the string and you are still, and in this you are traversing till the end and still you are failing on A, right? This might be the case, like let's say the string was YZ, then again yz, again a yz, and this string was this, right? So when you find this y, you go to this string, you find this z, and you found, when you try to find this a, you fail. So again you start from this z, right? So you try every, on every index you are going to check for the characters, right? So ultimately it becomes big O of n into m, right? Rolling hash helps you from this massacre, you can say, that you are traversing on every element. That's not good thing, right? What you can do is you can create a rolling hash value. What is this rolling hash value? I have been repeating it for many a times. Now I think I should be explaining that to you as well. So let's say if you had xyz and xyz, as of now take simple characters so that you can understand it, right? So what you will do is you will first find the window, the value of this window, which is exactly equal to the length, the t dot length, right? So you will find the value of this string. Let's say your t was yzx as of now, right? So what you will do, you will what do we do in general in rolling hashes? We calculate this value and then we calculate the substring, this windows value. Let's call this as val1. We check if the val1 is equal to this val, let's call this as val2, let's call this as val1. If it matches, then we have found that string. If it doesn't matches, what I do is I simply subtract this character's value and simply add this character's value in my string. That's it. And if this value now matches with this val, I can say, hey, I found the string. So if you look this is a sliding window thing, almost similar to a sliding window thing, right? That we are deleting a character and inserting a character at the same time, right? So if you think of it, what is the time complexity for this? The time complexity for this will be big O of n plus m, right? Or rather you can simply say big O of n. Yes or no? So see how smartly we have reduced the value from big O of n into m to simply big O of n, right? So this was the rolling hash technique, right? So in our case, we can see how do we find the rolling hash values as well. So if we had ABC and ABC, so what we will do, we will first find this window, right? We call this as 26 to, we will be taking the value as 26, right? 26 to the power 2, this will contribute 26 to the power 1, and this will contribute 26 to the power 0, right? Now it becomes very obvious for you that you will find the value. If how much will this a contribute, a will contribute 1 into 26 to the power 2. Why? Because a has a value of 1, b has a value of 2, c has a value of 3, d has a value of 4. Yes or no? E has a value of 5. Not because the position of the string, but in general ABC has this value. So a will contribute 1 into 26 to the power 2, B will contribute 2 into 26 to the power 1, and C will contribute 3 into 26 to the power 1, right? You will find this value, right? And now you will say, hey, the first string, let's call this was the, let's say, even string, right? Even was ABC, right? So you will say, hey, the first string contributed this much, right? Let's call this as val. Now what was our thought process? Our thought process was, we will try to find every value, every cyclic value, that is ABC, then BCA, and store the minimum out of this. So we will store this value, and we will store the val2. We will find the minimum out of all the val2 and val3. That's it. Yes or no? How will we find val2? We will simply subtract the contribution of A and add the contribution of this A. Yes or no? Right? So this was the value, the hash value of our string E1. Right? So I hope the logic was clear to you. The thought process would also was also clear to you. Let's look at the code now, right? Give me a second for that. Yes. So what are we doing? We are creating a set, right? We are creating an even string and an odd string. We will traverse from 0 to h dot size. If it's an even position, then we will add that character in our even string, else we will add it in our odd string, right? And simply have our even and odd string as well, right? Now what I'm doing is I'm finding the even value, right? So even value will be equal to find rolling hash value of string even, right? And int odd value will be equal to find rolling hash value for the string odd which we have generated, right? After that, we insert those values in our string. So what we will do, we will traverse on every element like this. uh, let me, yeah. So what we will do, we will traverse on every words, right? And on every words we will simply abstract this s and find the even and odd string and find the set value of it, right? And ultimately we will return set dot size. Now let's see the find rolling hash values function as well, right? So this is very simple. Whatever I have said is being written here, right? So what we will do, you will first, you have, as you are multiplying the, you are converting that length into 2 times that of length, right? So you will simply find the int n equal to h dot size, length will be half of the size of the string, right? And what you will say, val is equal, where have you multiplied the val, or we have doubled it, we have simply done here, right? String even plus equal to string even, that means multiplying the string by the size of 2, right? I hope that point is clear to you, right? Okay. So now we are finding, having a value, and we have a highest power. Highest power is nothing but that 26 to the power 0, 26 to the power 1, 26 to the power 0. That is the highest power thing, right? So we are going from 0 to length minus 1 and calculating the highest power of it, right? Now what I'm trying to say is, calculate from 0 to length, what is the value. Value is the hash value for the function, right? So what we do is simply do val into 26 plus num is nothing but ch minus a plus 1. So a will have a value of 1, b will have a value of 2, and so on and so forth, right? So we have a long rolling hash value as val initially. Now what we will do, we will simply slide our window, right? So we will start from length, we will go till n minus 1 and ch out. What is out? Out is the let's say, give me a second. So out is when you are at the string, let's say ABC, ABC, right? So this was the first string which you got. Now this character is out, right? So that is what we are doing. We are deleting this character and adding ch in, right? Or rather in character is this, right? Really sorry. So ch long num out, how much that contribution is, we will find that value as well. Long num in is the character which will be included, that is s of I, right? So val will be equal to num of out into highest power and plus num of in, val plus equal to num of in. So what we are doing, if the val is less than rolling hash value, initial value, then we simply can change it, or rather you can do a minimum as well, right? And we are simply returning the rolling hash, right? So I hope the problem statement was clear to you. The solution was also clear. The time complexity is big O of n in this case, right? And that's it. If you have any doubts, you can definitely do ask in the comments, right? I will love to help you out. And we have a Discord channel as well, so you can join there as well. I will be putting the link in the description. uh, that's it for this video. Meet you in the next one. Thanks for watching.